Mic check. Here we are. Hi, everybody. Hey. It's a wonderful evening. I did some prep work today. As you see here, I decided to start off trying to see if we could separate the stroke bordered view modifier from turning a shape into a view, keeping it as a shape. I think I've got something here. So let's test it out, and then I've got some more things I'd like to try with animations. Oh yes. Let's see. So okay, first of all, we were going to be doing a special SwiftUI stream tonight, but CocoType couldn't make it, so he's asked if I would postpone to Saturday. So we're gonna do the special Game UI stream on Saturday. So be excited. It's gonna happen. You too can have an influence on what gets worked on in this stream. All you gotta do is collect all them sweet 50,000 points and try your best not to spend them on the goat screams and you know, any choice of game you'd like. It's going to be a fun one, so stay tuned for that. So what do I got here today? Today is, first of all, I put a nice little note here. Normally, when you have a stroke bordered view, Matt, you just can't help yourself. It's okay. How are you, man? Nah. All good. Yeah, so you waste them on the goat screams. Yeah, I mean, if that's it's a close second. That's for sure. Yeah, absolutely. Can't ever get enough goat screaming. Yeah. For those of the you who are uninitiated, stroke border is a view modifier that effectively turns anything, shape or view, into a view. We like stroke border because it keeps the path inside the frame, the bounds of the the thing that we're drawing. Over to my right, we see a square and a circle. And normally, when you use something like this, so with the rectangle, you've got a shape, and you say, hey, give me the stroke border, and we're just going to do like a just your standard stroke style. What usually happens is, I guess we should probably do a line width, huh? Let's do a line width. Let's do 20. Looks good, right? And if that's what you want, great. Here's the problem. If I right click this turns into some view. What this means is we can no longer apply any shape modifiers to this rectangle. It's been stroke bordered, which means it doesn't go outside the lines. Whereas if you have a normal rectangle and you stroke with a line width of 30, border color dot red, and also give me that frame, that sweet frame modifier. What happens is you've got this issue where it traces outside the lines because the stroke begins in the middle, like right on the border. And if you give it a line with a 30, it's 15 outside, 15 inside. What stroke border does is it keeps everything inside the frame. And this is great. But what this means is you can no longer use this as a clip shape. For example, if you wanted to clip something or mask something essentially. Well, I guess you can mask with a view. But I like to keep things in the shape domain as long as possible. So here's what we got going on. Here's the original. Here's with the stroke border. Now let's take a look at what happens when we do this fun modifier. I'm going to take this out. I've got, let's do this. Temple. Here is our new and improved method. I'm gonna go 30. So it looks the same as the middle portion. But the great thing about this guy is that stroke bordered keeps it as a shape. This is great. It doesn't, out of the box, SwiftUI doesn't have a method like this. We had to make it. So we did an extension on shape. One of the things also that stroke border, the method, is it's a method that comes with shapes that conform to insettable shape. And which is fine because the built-in types, the built-in shapes that SwiftUI provides all conform to insettable. But did you know that you can inset manually and you don't have to have your shapes conform to insettable if you don't want to? Which means that any shape can take advantage of this stroke bordered shape modifier. As you can see here, insettable is not required. What we have is I've got a couple of methods here that I've defined. The first one takes in a line width argument and an optional trim argument. I'll get to that in a second. Still kind of working out the issues there. You have default values for both. 1 for a line width, trim is 0 to 1. And what this returns is some shape. And I have here a brand new type called stroke bordered shape. This is structured in the same style as the built-in shapes that include rotated shape, transformed shape, and what was the third one? Scaled shape, I think it is. Where you define it with basically a shape that you perform some transformation on. So I've got this content that conforms to shape. Stroke border shape is a shape itself, and it has the content. It has some trim value, and it has a stroke style. This is very important. The stroke style is what helps us perform the stroke border modifier. And what we do is we implement path in rectangle. What we do is I've created an inset rectangle that is taking the input inset by the styles line width over 2 in both DX and DY. This is actually something that the documentation says is performed on insettable shape. In fact, let's take a look. If we go back to, let's see, insettable shape. What happens is if you got, we have these methods. This is a protocol called insettable shape. For stroke border, again, this uses a stroke style like we do. Anti-aliasing, which we haven't worried about really. And there's two different methods. One is you can do it with a, let's see, stroke border S. Returns view this rule itself by style line width. Okay. I'm not sure what the difference is between this and this. Hold on a second. Okay. So you can do a stroke border on some incoming content, which is interesting. This is an instance method. So if I had a circle and I did a stroke border with some other content, let's take a look at that in a sec. But before we do, let's look at this guy. So stroke border and they all have the same oh, it fills it with content. Okay, so this must be a shape style, I'm guessing. The documentation might be not adequate here. But what essentially happens is it insets self, your shape, by style.linewidth over 2, which is what we're doing. Stroking the resulting shape with the style, yes, and then filling with content. And the reason why this is important is because once you fill, that outputs a view. And, you know, that's, if that's what you want, then great. But if that's not what you want, then we need something different. So these are all the stroke border methods that come with insettable shape. So we're just mimicking that and we're making our own. And instead of doing a fill, we're doing a stroke. Not too shabby, huh? So I'm going to move this over here and I'm going to take a look at this again. Stroke bordered, on self, where I've got a stroke style and the default stroke style has a line width of 1 and then it's got some default properties. But what I'm doing in here is I'm taking that inset rectangle, and then I'm returning the shape that we're holding on to. I do path in inset rectangle, which returns a path. And then I do this. I do stroked path, which returns a stroked copy of the path using the style. And then I also have this last modifier, which is still a little bit it's still a little bit crazy. It works, but I'm going to show you what happens when the trim is not from 0 to 1. And it's a little weird. I've tried actually like switching the order of operations here, and it doesn't seem to matter. But that's the secret sauce right there. There's our stroke bordered shape. Boom. Once you have this, you can stroke border anything. Keep it as a shape, because again, it's returning a path. Func path and rect always returns a path, and a path is how you draw a shape. And if you want to fill it later, then you can use like a fill style or a shape style and get your view. So this is what we have. This is the old stuff. Here's the stroke border. Here's the stroke bordered. And let's next look at what happens when you try to apply some trimming. Okay. Let's do some spacing of 40 so that we can get these guys further apart. Okay, cool. Now, what I've got going on here is once you do a stroke, you can actually, well, with this stays as a shape, yeah. So I could probably still do a trim from 0 to, let's say, 0.25. Okay. Now, this is very interesting. This is your normal rectangle, built-in shape out of the box. This is what happens when you do a trim from 0 to 0.25 after the stroke modifier. If you do it before, this happens. You're doing a trim on the initial shape. In fact, maybe I just double them so that I can show the difference between order of operations. Okay, I'm just gonna put some white space in here so I can see what's happening. We first trim the shape and then we do a stroke. Whereas if we stroke first and then we trim, this is what happens. So this is without the trim. This is with the trim. Pretty crazy, huh? So knowing that that's what happens to the built-in shapes, if we can replicate that behavior, but keep it as a shape instead of a view, then I think we'll be golden. Well, this is still a shape. But if I do stroke border, now watch what happens if I try to do a trim first. Trim from 0.0 to 0.25. Now, this is what happens. Once you trim, it complains. It says value of type some shape has no member stroke border. But I thought that rectangle was an insettable shape. It is. But now when you do trim, it just returns some shape. indeed, if you take a look at this, if we right click on this guy, it returns some shape. It doesn't return some insettable shape. We could try something like this, I think, as insettable shape. If I do this, if I surround it by parentheses, again, I'm trying to make this work with the original built-in stuff. Okay, so now that works, and then I do a stroke border. Is it gonna work? No, now it gets mad at me. It says type any view cannot conform to view. So we're at an impasse. How do we stroke border a trimmed shape? Apparently it can't be done with the built-in stuff, or else we're just not using this correctly. It very well could be, and maybe I need to be steered in the right direction here. But this is what we're working with, and what I think is unfortunate about that's one of the things where, because it's kind of a black box for us what SwiftUI is doing under the hood, it's kind of hard to see like why this is not allowed. So because of that, because we're stuck with that, my next choice is to say, okay, well, how can I do a trim from 0 to 0.25 and then keep that stroke border? Hey, look what we just did. Pretty cool. So again, the first box is a rectangle that's been trimmed from 0.025. It has a stroke of line width 30. It gets painted outside of the lines, outside of the bounds. We don't want that. We want it to stay inside. The second one is a rectangle that's been stroked first and then trimmed from 0.025, which gives us this weird effect we probably don't want. And then this third example is just, unfortunately we can't use, so it's just blank because I haven't stroked it. This fourth example is our own. Now here's the thing that is kind of driving me a little bit insane. Look at the starting point. Look at the starting point. See how it's like a little inset in here. This is the result of our inset. So way up here, remember we said our inset rectangle is inset by dx style line width over 2 and dy dx style dot line width over 2. And so it does that. Now, if I were to try to be clever and have this, it would get closer to the end. But as you can see, that's not what we want either, because now it's getting shifted up. And so like we truly need to have it yeah, we don't want that. So we're kind of stuck with this. The reason why this is the case is because if we go if this becomes the 0 point and this is 0.25, what happens when we make this 0.5, for example? Well, you're gonna round out here and then you're gonna get here, and so this is almost 50%. It's pretty much 50%. If you consider that once you do 1.0, of course everything gets filled. But there's this weird effect that I'd like to figure out how to resolve. Why can't I type? I think it's because my microphone stand is like right in front of my keyboard. I've got to get a better setup here. So the desk is like got this weird how would I describe it? It's like it's like a slopey it's not like a straight 90-degree corner. And so I can't put like the normal clamp that I use for a suspended microphone. I need to get a new one, or I might just need to get a new desk, you guys. I think this L-shaped desk is has definitely worn out its welcome, because I'm looking to change my setup here. I digress. Here we are, looking at this issue. Did my AirPods arrive yet? Yes, they did. Yes, they did. I've been using them. It's been a lot of fun. I've tried pairing them to my PC and my phone and my laptop, and then trying to like having them fight for like who gets the connection. It does get kind of wonky sometimes, but yeah, I definitely enjoy them. They're a lot of fun. But yeah, they're just sitting right here. Actually, I need to charge them. The main issue is when I open the case, so the PC like tries to connect, and then like I try to connect on the laptop, and sometimes it's like, no, I don't want to. So it's very finicky. I don't know what the deal is. It may be just because it's waiting to for Ventura to come out. But yeah, it's been great. Love it. The noise cancellation is like one of the coolest features, because I got this loud computer fan to the left of me, and like that just like masks out. It's amazing. You also experienced that same problem? Okay. Yeah, I wonder if Ventura is supposed to like resolve that, or I don't know. But yeah, Bluetooth is something I don't want all the time. Yeah, that's true. Yep. But holy smoke, it's such a game changer, like not having to be tethered with a wire. Like if I want to just like turn around and so I don't get like, clotheslined, it's the best. It's good stuff. Okay, so this is our current implementation, and I'm trying to see if there's anything that's that jumps out at me that I'm not liking here. First of all, well, I'll tell you what. I'm not using stroke bordered with the trim argument. Once we do that, I think that things might go maybe more our way. So instead of doing this, now I do this. Oh. Well, turns out that's not what we want to do. I get similar behavior to the second rectangle. It'll connect to something a floor above before the Mac right in front of me. Oh gosh, that is too funny. Even if you set this like right on top of the keyboard, it still is like, I don't see anything. What do you want from me? Yeah, it is kind of bizarre. I felt like I almost had to like restart my machine to give it a try, but I didn't do that. So this behavior kind of looks like rectangle 2, right? You stroke and then you trim. And I think part of the reason why is because we trim after we stroke. But if we were to change the order and go trimmed path first and then stroked path, aha, then we get the same thing. But look, it's still the same issue that we were receiving. So yeah, what's that about? What's going on with that? We still get the same thing with this trim argument as we do with the trim outside before we apply the stroke border. There's something going on under the hood that allows them to have this so-called magic. Again, if we do a stroke border with the full trim, it behaves like it should. But I need something that's like this, that doesn't go outside the lines. Why do you need that, you may ask? That's a good question. Let's see what happens when you do 0.5. So it's almost as if if we were to think of a bigger rectangle that was line width over 2 larger on each side, then maybe this would make sense to us. Again, I'm just talking myself through this to see if that makes sense. So I'm going to try this. I'm going to do this. I'm going to put a Z stack on this guy. And then I'm also going to draw a rectangle. It's going to be aligned with the, we're just going to say, we'll just say color green. Color.green. And this frame is going to be a width of, I guess it's going to have to be 256 plus 30, yeah? So 286 with a height of also 286. Okay. Now let's take a look at this again and see if what we're doing makes sense. Now I say, okay, I want my trim from 0.0 to 0.25. And it's like, okay, I'm stroking with the line with 30, which means I'm going outside the bounds, but my result is looking like this. And you know what would be even better is if I would have like a slider to like look at this in real time. Let's build that. Let's do that. In fact, what I want to do is rather than have all this inside the previews, I think we need to make a demo view. Yeah, stroke, bordered, shape, demo, which is a view, which means everything that we got in here, we're just gonna throw it. We're gonna throw it in there. And now what I get to do is I'm gonna create a private var trim, and this is a float. And what we're going to do is we're going to, let's see, make a slider. The value is going to be $trim. Label. Oh yeah, this does nothing, right? You can't see this. Minimum value label is going to be 0. Maximum value label is going to be 1. Okay, let's see what's happening. And then I just do this. I do stroke bordered shape demo instead. Shazam. Boom. Look at that. Hey, that's beautiful. Just kidding. It's inaccessible due to private protection. What? What? Oh no. What did I do wrong? Oh, equals 0. I think I need a starting value. Okay, cool. So this is what we got. Let's do that. And oh, you can see this now. Wait a second. This wasn't possible before. Wait a minute. This didn't used to. What Xcode are we running? 1401. You can see this. Folks, this used to be invisible to me for some reason. I'm not quite sure why. But if there is one thing I know, it's this is why. Because this is running on Mac OS. We're in our shapes library. That's why. This is running on Mac instead of iOS. Ha. But if that's true, then this is all iOS 15 supported, or Mac OS. What are we on? What is this? 12.6. This is Mac OS 12.6. Okay. Let us now play with Here we go. Unfortunately, it's being drawn outside of the page. So we gotta fix that, eh? This is where I'm kind of out of my element because I don't normally make Mac apps. So I gotta deal with that. What's a better way to do this? I could make it in a horizontal stack. I could do the top two H stack and then a V stack. I could do that. You say that every time and we say H stack. It is true. Why do I do V stack all the time? Why do I do that? All right, fine. Yes, this is the way. You're right, Matt. Hey, who'd have thought? Hey, look at us. Although, wait a second, the slider has to be, it still has to be in a V stack with a slider. There we go. There we go. Getting called out. Hey. Wait, let's try this again. Here we go. All right, cool. You can see this. Yay. You know what? Oh. I keep on bothering CocoaType, telling him that he needs to start making some Mac programming tutorials. Okay, so this slider isn't actually attached to anything yet. So let's fix that. We're going to do this. Trim from to this. Wait, I don't need the $sign, do I? I don't think I need the $sign. Oh gosh, it has to be a CG float. Oh, I didn't mean to build. I meant to copy paste and I accidentally command bead. I command bead. Yoink. Okay. Bring forward. Oh wait, do I need to build first before I do that? I can never remember the order of these things. Okay. Hey, look at that. Ooh, what is happening here? Okay. Here we are, starting at 0, going to 0.25, and look at what's happening with this guy. This is getting painted like it starts here and then it does this like, look at that. That is bizarre. See how the line is like doing its thing? That is so fun. Okay, so this is 0.25. In fact, we should be able to, you know what we should do is instead of you can see this, we could do, we should make this trim string value. String trim. Oh, but wait, what did we want to do? We wanted to do a format. Percent 0.02 F trim. Okay. Here we are. Okay, cool. So here we are from 0 to 1. So what's happening here? So we should label these ones too. We should label these ones too. What's the best way to do this? Maybe just a text saying. Wait, does that not work? Hello, neighbor. Does that work? Insufficient indentation of next 2 lines. and multi-line string literal. Wait a second, really? You have to worry about indentation with these triple quoted strings? I had no idea. Would you look at that? Okay. Let's bring this forward. Okay, sweet. So this is rectangle, trim from 0 to trim, stroke line width 30. Yeah. As we can see, because it paints outside the lines, and this green line is the actual border, it is behaving the same way as if from 0 to 0.25 as this guy is, but he's staying in the lines. So for this reason, it seems that our implementation is doing what a trimmed, stroked path would do. You can even see it here in the corner when it's finally reaching 100%. That last little blip, does that. Okay. Which means I feel like we're doing what we should be doing with that. Now, what's going on here is just plain wrong. This is strange. Oh, and look what happens when you go from 0 to 1. You paint, and then it paints. This is 50%. This is 50%, and then it paints again. And look at there's like the winding rule going on here. It's painting over. It's like shh. You get the same result when trim is 1 with this guy, with the stroke and the trim reversed. That's crazy. That is crazy. So let's document that. Oh, it's gonna get mad at me, isn't it? You're supposed to indent the same across all the lines. Okay. And now, I guess we're gonna do the same thing on all these guys. It's probably a better way to do this, but I don't care. Rectangle, I guess it's this, because even though we commented it out, we gotta make sure that it's staying true to its roots. Okay, and now finally we've got our hero. Z-Stack. And you are, well, I'm not sure what this is doing each time. I guess we're gonna have to change it. But let's just say it's this stroke bordered. Whoop. Build. And run. Guys, I saw Johnny Mnemonic yesterday. Cross that off my bucket list. It was campy. But at least I've seen it. Ruh-roh, looks like this gets, well, I guess towards the end it's fine. So here's the result. Here is the stroke bordered result for 3 and 4. Obviously, it does not support trim. 1 and 2 do support trim. They're drawn very differently. It would seem that if you want a trim that's less than 1, you want to trim before you stroke. That's what we've learned here. But this is insufficient because it's going outside the lines, and therefore we need a brand new method. Even though this stays as a shape, it's not giving us what we want. We could, to be fair, we could inset this by line width 15. Let's do that. Let's give it, let's give it a chance. Let's give it a chance. So this was the first one. This is the trim, and then this is the stroke with the line width 30. So if I do inset, wait a minute. I can't do an inset. Can I not inset on a trimmed shape? I think that was the issue, right? Yeah, inset by, let's say 15. And then trim. I'm going to have to do this. Dagnabbit. There's no, like, fast way to do the auto indentation, is there? Oh, maybe there is. I didn't even try an auto indentation. We should try that next time. Try again or make another change to your code. Or try again. Okay. Hey now. Look what we got. Look what we got. We've got the same. There we go. Rectangle, inset by 15, trim from 0 to trim, and then stroke. Okay, so we have essentially, we've got 3 steps in here, and now we finally have what we want with the shapes library. Sorry, not shapes library. With the built-in shapes. We are doing this in three modifiers. Okay, not too bad. I imagine we would get similar results towards the end of the stroke here if we did it inset as well. So maybe I do that just for completion's sake. There you go. I'm gonna try this now. Control I. Oh no, Control I doesn't work for formatting triple LUTs string constants. That's too bad. Okay. Rectangle inset by 15, trim. There we go. But isn't it cumbersome to have to do this? Yes, it is. Therefore, we have our stroke bordered, which does the exact same thing. And again, you know, the insettable shape protocol tells us that this is what it's doing. It's saying, by the way, all I'm doing is insetting self by style line width over 2, stroking the resulting shape with style, and then, well, not filling with content because we're not filling. But it doesn't allow for trimming. Does it? It doesn't allow for trimming because we tried it here and it was like, no, I refuse. And we were like, why? And they were like, we're not going to say why, is you just can't. You can't do it. And you're like, oh man. And that's just the way it goes. So because of this limitation, we came up with our own method that does all this together. But the only problem with this is this trim argument. It's kind of awkward to me. Maybe I shouldn't worry about that so much. Because what I could do is I could trim it here and then just get rid of this guy. And I'm pretty sure we get the same result, yeah? We have a trimmed shape and then we stroke border it. But then that's two modifiers. But what does it matter if we're just doing multiple modifiers inside the draw method, you may ask? And that's a valid question. It just becomes ease of use. I mean, that's what all methods are anyway, right? They're performing who knows how many number of calculations under the hood that you don't know about. But the call site, the interface, it's got to be helpful to use. Wait, why is this? Oh, because the trim's not happening. Yeah. Okay. I meant to do this. There we go. Build again. Can I convert? Oh yeah, I gotta do CG float. Guys, I need to find a new playlist. There's a really cool playlist that this streamer I was watching last night was. Let's see if I can find something similar. Let's try synthwave. All right, we're gonna give this one a shot. Bring forward. That's what we got. Okay. So we don't want stroke trim. We want trim and then stroke. And I think that's what we did in our actual shape. Yeah, we did trim and then we did stroke. If we wanted to create a trim of a trim, what does that do? What does that do? Does it just, is it trimception? Let's find out. We're gonna, so we have our fourth example. In fact, you know what I feel like I shouldn't even like bother with this guy anymore because obviously stroke border is not possible. Maybe I just keep it as an example. Okay, so then I do this: a stroke bordered trim 0 CG float trim. I wonder if it'll have an effect. It might and it might not. Let's find out. Okay, so yeah, it's basically doing, so it's multiplicative. So you're doing 0.25 and then you're trimming that down to 0.25, which is why this is a quarter of that. And then if I go to 50%, then this is 50% of that 50% and so on until we get to 75%, which is, yeah, I guess that makes sense. Okay. So we either need to do the trim as the first modifier, or we need to just include it as part of the call, which is fine. Even though this is like weird, this second one, I really love like the way like the result is, just because of the way it's painted. That's kind of fun. Hooray for the winding rule. Okay, so, but we don't want, unless it's on purpose. But no, having a single shape modifier is much more user friendly than having to do inset, trim, stroke. Yeah, I would say so. So yeah, so to conform to insettable shape, not necessary. You can just do inset by. Well, I guess it depends. Well, okay, so I lied. If you don't want to use like a homegrown solution, any shape that you use, you're gonna have to make it insettable so that you can actually call this method. I guess that makes sense. Yeah. Okay. I lied. Compile Swift, what's up? How you doing? Square's doing things. Square's doing things. Hey, check it out. What we're doing. What we've done is we've extracted the stroke border functionality of the insettable shape protocol, and we get to keep it as a shape. Isn't that great? I think it's great, and you can do it on any shape. It doesn't have to be insettable. So this requires an insettable shape. For example, any built-in shape. Rectangle, circle, ellipse, capsule, whatever. If you're doing your own solution, inset will not work. Instead, what you'll want to do is use our new and improved stroke bordered method, which can take any shape, not just a rectangle, and apply this this function to it. It's an extension on shape. I've got two methods that I've called here. One is line width of 1 with a trim, which defaults to 0 and 1. The other is using a stroke style, and spoiler alert, this is just using the same thing under the hood. Although, actually I forgot to do a trim. What have I done? Continue to be the Lord of the Shapes. Just call me Michael Flatley. Style, trim, Michael Shapely. Trim equals, okay, so again, 0, 1.0. Sweet. Only I can't dance. That's the main difference between me and Michael Flatley. Yes. Also, I'm not a superstar 80s icon with the bouffant. I expect to dance now, Matt. That's gonna cost you 100,000 points. You're gonna have to start. You're gonna have to stop using those goat screens, my man. Oh shoot! No, we got to get that in writing. I am considering updating my rewards list, so we'll see. Rumor has it that he can't program, so that evens it all out. Yeah, I guess that's true. That's true. We're okay. So the score is tied, Michael Flatley. It's your move. All right. So here's what we got. We have two friendly methods for shape that are just an extension on shape that give us a stroke bordered look. The first two that you see here are the methods that are required to get the same effect as one call over here on the right. This third guy doesn't work. Stroke border, yeah, we just show this because he's sad. And so I'm happy with this, and I feel like this is a great addition to the shapes library, and so that's why I've got it in here in the project. And we're going to commit this today. I'm very excited to finally get to make a commit to this library. It's been a while. Stroke bordered shape. This is it. Which means that stroke styled circle, for example, we could utilize this under the hood. And so like right now, I'm doing this again. I'm doing this by hand. I'm saying circle, inset by, stroke width times 0.5, trim, path and rect, stroked path. Now this is very interesting. I just realized that we did path in rectangle as the third as the third modifier here. Oh, wait a minute. Let's look at this. Let's look at this. Hold on a second. This changes everything. No, it doesn't change everything. I'm very interested in why I made this choice. Let's take a look. 100,000 points for me to dance. Oh shoot. Oh no. Luckily, none of you have the discipline to stop from using those points, the sweet goat screens. I think I'll be safe. Although I do worry about Cocotype actually saving up for it. Those will be my famous last words. Jojo, thank you so much. Thank you. Woo woo, indeed. 3 months. I appreciate you. 3 months in a row. Excellent. How are you doing today? How are you? All right. Where were we? We were in the stroke bordered shape. Yes, sirree, Bob. So the path in rectangle does this. I say, here's my shape. Okay. And here is path is circle. Inset comes first. I know why I did this. I'm looking at this now. It's because I'm not starting with a path. I'm starting with a shape. So this is actually okay because it kind of forced me to be like, oh, circle. Luckily, it's an insettable shape. Yeah. Because it's essentially what we did over here, all the way down at the bottom here. See this rectangle, inset by, trim from to, trim from to. And then instead of path in rectangle, I just do, and then stroked path, I just do stroke. Where, you know, right now this is just like with your standard, you know, stroke style with no dash pattern or whatever. But that's beside the point. We still have to do all these things in order to get this work for the circle case. He is a hoarder. That's right. He was using those points. He was saving up. The last like 3 streams, he was counting down or up to 100%. And at first I didn't know what he was talking about. He's just like 87%. I was like, what? It finally dawned on me what he was trying to do. And I'm so happy that he did though, because it's going to be a fun one. So that's being moved to Saturday. So we're going to actually do a special SwiftUI game UI stream just for Cocotype, who redeemed 50,000 points for the game of choice. So all of this calculation going on here at the top, just leading up to building a stroke style inside this shape, which is just taking a circle and performing all these things. It's like a wrapper to a stroke bordered, stroke styled shape. All of this is happening here, and we were able to do it just like this. So we've compacted the process, which is great. This is really great because I'm just trying to remember if there was a use case here that like wouldn't work for here. And I think this would be it. The stroke style you could bring in as you could bring it in as an input argument. So this stroke style, the calculations happen all the way here to make sure that we have like an integer number of sections that we can make sure that we have we fix that discontinuity thing, right? What did he pick? I bet he picked something Mario. So he did announce it in stream. So he wants me to do something from GoldenEye from N64. There's a menu that he took a screenshot for me and he sent it to me. So we're gonna do that. It was not Mario, Compile Swift, believe it or not. GoldenEye, one of the top 100 games of all time, in my book. Probably ranks up in the top half. Top 50, yeah. No, it should be fun. I'm excited. Okay, so hey, this is really cool. I'm very excited about this. This right here, boom. And we have an extension on shape. So everybody everybody wins. Everybody wins. Look at this. You don't have to have an unsettable shape. All you need is my good friend stroke bordered shape. And that is my gift to you, SwiftUI developers. Boom. I'm sure someone else has already done it before. But hey, we did it live on stream in front of millions of people. I mean 6. But it felt like millions of people just because I could feel the support from all y'all. It was great. So many hours playing multiplayer back in the golden days. I remember completing that, I think. So, who was your favorite character? Do you remember? When you played multiplayer, was Oddjob like outlawed? Was Oddjob banned from your multiplayer sessions? I can't remember what I had for supper last week, let alone 30 years ago. Yeah, that's true. That's fair. I mean, you know, we have these weird indelible memories that just kind of stick with us. For me, it's like weird commercials that, you know, that I can quote from whatever, or movie quotes, Simpsons references. Yes, of course. But, you know, game sessions. I remember it was like, no Oddjob, no Oddjob. Well, why? Because you can't hit Oddjob. Is, you know? All right. So step 1 complete. We've built this. This is great. And I'm going to see, is there a way to actually do this? I wonder, I'd like to refactor this. I'm going to X this out. I'd like to refactor stroke styled circle, polygon, and rectangle to, because they're three different shapes, right? They're 3 different shapes, and you know, they've got a lot of variables, a lot of you know, I kind of feel like I want to turn this into like a stroke style factory for a given shape, so that I can take so that I can figure out what the path length is of that particular shape. And then the calculations are done for me, right? For example, for a circle, we have to know what the radius is. Well, if it starts with the line width, then we have to like subtract like line width over 2 to get the actual radius of the circle, right? And then that's how you get like the path length is the circumference, right? And that's a well-known equation. I remember quoting most of the movie Aliens dialogue and driving people nuts. Game over, man. Yes. Classic. So this is what this is doing. The dash length is equal to pi times the diameter, or dim, which is the minimum of the width and the height of the inset rectangle, divided by the number of segments, is a dash length. And then I had this weird thing over here. I think all this stuff is probably unnecessary once I get this factory working. In fact, I would like to take a look at how to calculate a path length. Because if I could do that, then with floating point accuracy of like what you got 6 decimal places, right? That's all you need. If we could do that, then all of this stuff would just be like unnecessary. And we wouldn't even need 3 different types. We wouldn't need a stroke styled polygon, a stroke styled rectangle, a stroke styled circle. We just grab our stroke style from the factory by taking its shape and returning the path length. I think the only thing about that though that is It would have to be like an internal thing because you can't know like the actual dimensions of the shape until you actually have it drawn at runtime, right? That's when path in rectangle is called. So, you know, oh, this is the wrong one. Trapezoid. Yeah. So when any shape's path and rectangle is called, this is when you're like, oh, okay, I've got my frame, I got my bounds. Now I get to calculate, knowing what the stroke style is, extract the stroke style from, well, wait a second though. No, the stroke style is independent of the size, isn't it? No, but it gives you a line width parameter. So if the line width parameter is 30, I'm just thinking about this a little bit. Right? So let's go back to our stroke bordered shape example. We have a stroke style that comes in. The default value is 1, a line width of 1. But if you wanted a line width of 30, right? You got this line width. So the stroke style with line width. That stroke style has that line width. And if this is the call site, then we're okay. It's that whole like line width ratio thing that I was trying to mess with before. You guys recall this, right? Like we go stroke style to, do I even have the demo in here? Where you could like go between 0 and like 50% of the diameter, and then like you can see how like the shape line width gets huge. And you could create like these like swirly patterns and stuff that go all the way to the center, like, you know, like a peppermint candy or whatever. And that's why inside here is where the stroke style is actually created. It is created here because the line width gets actually created from the line width ratio. It has times the diameter. You got the stroke ratio going on, which is like, yeah, it's just a bunch of math. And it's a little convoluted. It's probably more difficult than it needs to be. But what did I say we were going to do? We were going to explore path and see if we could get the path length. Let's go to documentation. Let's go to path. And let's see if there's a length property. So path is an outline of a 2D shape in SwiftUI. It is heavily related to the core graphics path, or CG path, because it turns out that you can get a CG path from a path, like so. Getting the path's characteristics, you got the path. You've got a bounding rectangle that contains all the path segments, which is kind of neat. You've got contains, like whether or not a path contains a specified point. You've got the current point in the path. You've got the description. Wait a second. A description of the path that may be used to recreate the path via init. Oh, that's interesting. What, so you can store it in like in a string format? Oh, this I gotta see. Hold on a second. Hold on a second. Can I print that out? Let's go back. We have to go back, Kate. We have to go back. Stroke bordered shape. Oh, and let's not forget Path Builder. Holy smoke. Hey, we've done a lot in the last couple of weeks that I actually haven't committed to the repo. Actually made my first result builder a little bit ago, where we were able to actually like add paths in a way that's more SwiftUI-y. Wait, so the description contains a copy of its initial state? That's what I'm about to find out, Compile Swift. I think you're right. I think that's what exactly what it's saying. Yeah. So let's take a look again. So my demo here is going to say rectangle, stroke bordered, frame, and then I guess the text. could replace this with okay, this will be kind of weird. Hold on a second. It'll be, I'm going to do this. Let description equal, okay, hold on. Let's be smart about this. Let my stuff equals rectangle stroke bordered. Then I'll say let description equals my stuff dot path. Oh, I guess I should do path and rectangle, because I got to get the path first. Path in, I guess it's going to be CG rectangle. We're going to do origin size 0, and size is going to be 256 by 256. So that's my stuff path. So that returns a path, and then all of that dot description. Yeah. And then, so I get rid of that. So then I'm going to call my stuff dot frame with border text. Now instead of this guy, well, let me just do this. Let old label equal that. So we'll see. So then this text guy, this text is going to be description. Let's see what this looks like. You guys ready? So excited. Build and run. What? Infinity, infinity, M, infinity, infinity, L, infinity, infinity, L, infinity, infinity, L, H. Oh, here we go. What the freak? What the freak? What? What? What is this? What is this? This is madness. 1530M, 241, 30. Is this a bar? 226, 15, 226, 227, 4348. The matrix is real. Look at what's happening. And as we get bigger in our path, the string gets bigger and bigger. What? Oh, hey guys. I don't know about you, but that seems a little interesting. We can actually create a shape with this string. Agents are coming for you right now. Knock knock, Neo. What are you saying, that I can dodge bullets? Do you want to know what it is? Okay, so this is here's what I can identify. So 15 is the inset. 30 is the line width. What is M? What is M? Is M stand for move? I'm saying in Matrix 4 you won't have to. Did you watch the latest Matrix film, Compile Swift? Now this is interesting. With a trim of 0, I have infinity, infinity, M. Infinity, infinity. What is that? Is that a bar? Okay, here's a, you know what we're going to have to do? We're going to have to, why can't I copy and paste this? Should we use a Swift playground to like, take a look at this? Let's open up Mac Playground is better dot playground. Or Mac Playground is better dot playground. Yeah. Oh, this is what we were using to test out the result builders. Got it. Okay. Let's just make a new one. New playground. Oh, actually, wait a second. Could I use the terminal for this, the Swift REPL, and does Swift REPL import SwiftUI just fine? Sadly, yes. You saw the fourth one. It was a little bit different than the previous films, huh? Matt says worked with the guy in the past. So the last name was Anderson. So every time we had a meeting, I came with Mr. Anderson. We meet again. I'm so happy to hear that you did that. I have a friend also with the last name Anderson, and I can't not do it when I see him. It's amazing. Don't know about the REPL. Hey, let's find out. Let's find out. Here we go. Swift REPL. Import SwiftUI. Oh, okay, I did it. Okay, cool. So let's let shape equals rectangle. Okay. So SwiftUI.rectangle. Ooh, this actually might be really fun because we could probably get in real time some type information. Oh. Hey guys. Okay, so if I say what's my shape path in path in CG rectangle, let's see. How do we do this? Oh no, what oh dear. I pressed the tab key. That was not good. More abort. Have any of you guys used the Swift REPL before? I actually recommended it to a streamer last night. And I'd never really used it myself. I was like, you can do it because they were asking, hey, is there a Swift REPL? And I was like, there is, but I don't normally use it. That's why IDEs were invented. That's true. I feel for that guy after years of Office Peter jokes. Roll with it. Come back with a Peter laugh. Compile Swift. Do you do a Peter Griffin impression or not Peter Griffin? Peter from the guy from Office Space. Is that right? I wish I could have made the Michael Bolton face. Have you reenacted the printer scene? That's one of the best scenes ever made. Okay, so here we go. CG Rect is going to be 0. Dot init. Let's say 250. Do I have to do it with this? I guess I have to do it with this. Height 256. Yes, I know this is why IDs were invented, but I just want to check this out. Oh, shoot. I had a friend made a perfect replica of that scene. Oh, that's awesome. Oh, I did iPath. Let's say let path equals shape.path in CG rectangle dot 0 init width 256 height 256. And I forgot to do that again. 1 2. Missing argument labels origin size. Gosh dang it. Hold on. Oh, it won't let me. I need to do size. Origin 0 size init. Okay, cool. There we go. I had a friend made a perfect replica of that scene, and Stephen Root is best. That movie's so good. It's so quotable too. That's definitely a must see. Okay, so I've got my path. So if I say path.description, because this is what we came to see. Okay. It's not a bar. It's an L. It's a lowercase L. Very interesting. Okay, so 00M 256 0L 256 256 L 0 256 L H. What is this madness? Side note, they made the movie just down the road from my old office. Dude, that's awesome. That's pretty cool. You got a little piece of Hollywood history right there. So if I were to say, so if I have this string, I could say let constructed string equal constructed path equals path. Whoops. Shut up. PO. Wait. PO doesn't work for Swift REPL, does it? PO constructed path. Yeah, PO doesn't work. PO is only for the debugger. Now we need that in all shape descriptions. Yeah, we do. So yeah, what does this mean? That's what I would like to know. Deconstructing a path description. I wonder if that's actually documented somewhere. Should we check? SwiftUI path description. What's a good search term for that? String formatting. Is the SwiftUI paths object string format a standard? I'm exporting SwiftUI path objects to strings using the description property for storage in a database. What do you got to say? Hey, here it is. Here it is. This is an example of the format that it produces. 00M10L. This can be used later to initialize a new path object, recreating the path. Okay, okay. I'm not overly familiar with vector paths. Is this a well-defined format, perhaps a standard? Or is this something that is specific to SwiftUI? M probably means move. L is line. H might be close. Looks like the path construction operators as used in PDF. M equals move to, L equals line to, H equals close path. Compare with 8.5.2 path construction operators in the Adobe's PDFs of something. It looks familiar to you? Oh, it's a 404. Man, this ain't my dad. This is a cell phone. Thanks. Yeah, it does look like it sort of follows that. But then looking at some other operations, you can add quad curves, which are signified by a Q operator, which I don't see in the PDF spec. I see. So it's probably similar to or inspired by the PDF operator. So you would have to reverse engineer, and that might break in the future. A better option might be to enumerate its CG path using the apply with block method, which is documented. Oh, okay. CG path apply with block. Okay. We're getting closer, guys. We're getting closer. CG path. Apply with block. Oh. Is it though? Is it really documented though? You sure about that, guy? Okay, CG path element. Let's see, a data structure that provides information about a path element. Okay. Init type, CG path element type, points, unsafe mutable pointer, CG point. Element type, what are you? Ooh. What do you got here? We've got a move to point. Okay, this is an enum. This is an enum. We've got a move to point. We got an add line to point. We got an add quad curve to point. We got an add curve to point. We got trouble. We got close subpath. Let's take a look at this. Ooh, close subpath equals 4. Very interesting. This is where we discover it's all a lie and SwiftUI is just a PDF renderer. Wouldn't that be amazing to add curve to point equals 3? Oh, these are just okay. So the enum is a type int32. Okay, that makes sense. That makes sense. Okay, so this is just giving us numbers. Move to point is 0. Add line to point is 1, and so on. Add quad curve is 2. Yeah, and then 3 and 4. See the function close subpath. Appends a line from the current point to the starting point. So what does that mean for us? If we go back to our REPL, what do we see here? 00M 256 0L 256 256 L 0 256 LH. Yeah, that doesn't really give me much. It is a cover up. Okay. But CG Path has been around for a long time. It seems like we should be able to, I mean, it's been around since iOS 2.0. Yeah? So it seems like we should have all we need to kind of break this down. Change your height to some other number so you know which is which. Ooh, I love that idea. Let's do that. Let's do that. Let's do that. All right. Oh, I made it let. Man. Okay, I'm just going to do this. I'm going to height. Let's do 512. It's going to get mad at me. Oh, actually, it was okay with me doing a let path again. Very interesting. So then path.description 00M 256 0L 256 512. Hey, this is kind of neat. This is kind of neat. Maybe let's change the origin too, huh? Maybe the origin. Let's just let. Whoops. Oh, I can't do Command Z. Abort. Okay. So I'm gonna go 256 512, and the origin is going to be. Is it CG rectangle? No, that's a. CG point. Thank you. I'm gonna say X is 1 and Y is 5. There we go. Now path.description. Hey, look at here. Look at what we got here. Okay, so let's map this out. So essentially, this is the origin, is the first 2 points. And then I have M. I'm not sure what that means. What is this? Move to 257. Since X starts at 1 is a width of 256, that means 1 plus 256 is 257. Height 512 plus 5 is 517. But it starts at 257.5. L 257 517 L1 517 LH. Oh yeah. Okay. And this, I mean, this very well could be the fact that circle uses an arc under the hood, yeah. I guess that's what it uses. Let's try another shape, shall we? Let's say let rectangle equals rectangle. Is that how I did it before? Already have shape. Wait a minute. No. I already am using a rectangle. I'm already using a rectangle. This is a rectangle position. Okay, let's this is a rectangle. What I really should be doing is doing this. Instead of rectangle, I'm just gonna let me in. Let me in. Okay. Go back to the Your Mac app and watch those numbers change as you go through it. Yes, that's what I should do. You're right. You're right. Let's go back. Let's go back. So 1530 is, again, it's the origin, right? So because we are inset by 15, but why are we inset by 30? That doesn't make sense. Why is the origin 30? Oh, I guess because it starts here, technically, doesn't it? The stroke starts at the bottom. I guess that tracks, doesn't it? I did have a spacing 30. Yes, I did. Yes, I did have a spacing of 30. Would that do it though? Maybe let's change the spacing to be something like that's not like an even number. Or not like a number that we did before. Yeah, our spacing, no, our spacing here was 40. Our spacing was 40. I'm going to change it to 42. The secret of the universe. The answer to the universe. And let's see if that can give us some... if that can give us some... I probably just... My Google skills probably just need some work. Yeah, so spacing 42, 1530 seems to be the inset in X, the inset in Y, where the stroke is actually built right here. It'll be your line width. The line width is, I mean, that's the origin though, right? 1530. According to what we found in here. This is the origin. 15M. 1530M. And then what does this go? This goes 257, which is the width plus the origin. So this is the width plus the origin. So we're at 64. And so if we go all the way here, I see how that 241 like stays constant. And then as we go back, it still stays at 241 that whole time, doesn't it? Hey, very interesting. We're demystifying the CG path description. Or no, I guess path description, path.description. Yeah. Has someone seriously not done this before? They had to have done this before because this person asked about it back in 2021, July 9th. So here's what I think. The moment that it changes, it goes from the path drawing this way to drawing downward. That's when we start to see a change. We start to see a change in the length of that description string. Yeah. If that person has never been heard from again. Something about Apple MIBs. Yeah.
Now we've just got to do one last thing, an eye exam. We're not hosting an intergalactic kegger.
That's my Rip Torn impression. You're welcome. So let's see what's happening. Let's move this over here real quick. Whoops, daisy. I meant to do this. Okay. It's because of the trim. Bloop. Like it immediately goes bloop. Not bad. Thank you. I haven't practiced my Rip Torn in a while. So this seems to be the end point. The start point is 1530. The end point is 1630. And then the width. No, not the width. 1530 move to 1630. And then what is L? L is 16 0, L 15 0, L 15 30, LH. That must be the coordinates of the stroked path up to this point. Yeah?
Yeah. Oh yeah.
I need to put this in like a document somewhere. Okay. So if I've got this going on. Ooh, it even keeps the color formatting. That's kind of cool. So 1 and 5 are is the origin in points. M is, don't capitalize M. M seems to be moved to ? And then 257 and 5 are is the CG point bottom left, I think, of the final of the path stroke. Maybe. Maybe. 257 and 5 is, so 257 517 would be bottom. Wait, no. 270. No. That's not the bottom left. That's the top left. 257 5 means, is it? No, I'm confusing myself. I need to stick with the path with the trim, is what I feel. What I think I need to do. Okay. Maybe I just need to add the trim modifier in there in the REPL. So 255 and 7 is 257 is origin.x plus width. 5 is origin.y. So 257.5 seems to just be origin x plus width, comma, or CG point x origin.x plus width, y is origin.y. Yes. 257, and then L. L is, what is L? Question mark. 257, 517 bottom is CG point x origin.x plus width. Y is origin.y plus height. And then another L. And then 1, 517. Another L. And then finally H. Okay. Riveting. I know. It's amazing. H seems to be the last thing that you see no matter how far you go. Like you see H going here, and it's always, it's L and then H. It must be like the final countdown. Although, once we close the shape, things get interesting because this is the same thing, but with a full trim. But you see how there's a lot more numbers here now. In fact, let's color this text foreground color. Gosh, what's a good color that's not gonna gouge our eyeballs out? I guess let's just do gray. Let's also make it. Let's go bold. Yeah. Okay. Here we go. Let's go again. This is kind of a tangent, but kind of not, because I just want to see if I can construct a path just from numbers. That's going to be really powerful to add to our kit. You know what I mean? It's one of those things that's maybe not very like exciting to see, but like, wait a second, why are you not? Did I do the wrong one? I think I did the wrong one. Gosh dang it, I did the wrong one. It's over here. I did it over here. Yeah, shoot. I didn't mean to do that. Bold. Foreground color gray. Okay. Let's do that again. Once this is done, I do want to try another thing that's completely separate. So don't worry. I'm not gonna spend too much more time on this. I am curious though what's happening. Okay. So here's what's going on. We have 1530, which is the origin. 1530 starts here. We then have 24130. Now the length of this is, well, the frame is 256 by 256. However, 241 is 256 minus 15, which is half of the line width. So the width even though our frame is 256, the width of the actual stroke is only 241. Very interesting. Because it goes all the way to here and it stops. And then something interesting happens. Then we get this 226.15, 226, 241, a bunch of L's, and then it just starts repeating itself like crazy. Not repeating itself, but like adding more and more. More and more. So let's see how long we can deal with this. So the length, so it's like, it must be like the final position. So that decimal number that we see going up after the M, that's the final position. Notice how this 30 never changes. But then this thing is going on. This seems to be, it's not the width, it's the same number here, 158, 150.28. These numbers are the same. These numbers are the same, and they continue to just be the same all the way until, boom, something happened right here. Not here or here so much, right here. It went from 1530, 238.30, 238.0, 15.0, 1530H to, oh, see, it's wrapping, so it's kind of hard to, oh, maybe I do this. Maybe I don't draw the other four. The other three, I mean. Let's hide these guys. Let's hide let's hide the first three. And let's just focus on the good stuff. You ready for this? Boom. Try again. Is this interesting? Well, it is to me. Yeah. Okay. 1530H. So this is 1530, blah, 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 0 to 15H. And then it does that. It immediately doubles its length. Where is the first 1530? It's no longer there. The 1530 is no longer there. But there is one over here, which makes me feel like this is almost like a tag, like an HTML tag, yeah? Let's see if there's any more M's. There's no more M's. It's just M. It's just M and then L, 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 L. If you could really reliably deconstruct these paths, think how small a shape file save could be. Very small. Yeah, that's true. And we could even, like, I wonder, because there are some people out there that have made like a SVG converters, SVG to SwiftUI. I wonder if they actually were able to construct the shapes using this. I wonder if this is the secret sauce. We could make our own SVG converter, you guys. Wouldn't that be fun? That'd be a fun project. Listen, it already exists in the world. Everything you want to do, everything you have an idea about, it already exists out there. Yeah? But the joy of learning, of building your own, of creating, the discovery process, you can't duplicate that. Yeah, sure, you can you can download somebody else's Swift package. And I highly recommend you download mine. But it's the learning process that like sparks joy, yeah? If only there were adequate documentation from our friends in Cupertino that could help us go much faster. So yeah, we've got a series of paths that every time we change direction, it adds to the pile. And this makes sense. You're doing an add line, followed by an add line, followed by an add line. That's what a rectangle does. We are seeing what's happening under the hood with Apple drawing a rectangle. They're just doing add lines from point to point to point to point to point. That is all it is. And that right there, my friends, that is the string that generates a trimmed rectangle. It is satisfying. It's just like Snickers. What does a circle look like? You guys ready for this? Swiggle. I know I said I was going to move on to something else. We'll be there in just a tick. Oh, snap. Already you've got something going on here. Boom. What is this? Oh, we've got a C in here. Ah, a C, which I think might mean curve. Yeah. Curve. There's a C, but then there's another C. And these values, oh, they do change a little bit. C, then goes to C. There's 2. There's a 3rd and a 4th C. And now there's a 5th and 6th. Why? Why? And now a 7th and an 8th. Why? Is it because there's 4 curves that's generating this circle? Wow. That's interesting. There's probably a whole library of them CRT. Yeah. Yeah, I bet you. Are we making Coco's GoldenEye? Ploppy, Coco Type messaged me today. He said, I can't make it tonight. Is there any way we can do it Saturday night instead? And I said, yes, absolutely. You spent your 50,000. You get your stream. So we've postponed it to Saturday when he'll be here. But yeah, we'll definitely do it. It's on the menu. Right now what we're doing is we're actually looking into how to recreate a path from a string representation, which is just the most bizarre thing I've seen in a very long time. But it makes sense. Like this is wild stuff. Wild stuff. So C, I think, stands for curve. Yeah, I wouldn't even know where to start with that. Yeah, we don't either. We're just kind of learning this as we go. We're just kind of figuring out what works. Actually, the reason why that we started with this was because I was like, hey, I wonder if I can find the length of a path. If I could find the length of a path, then when I do my stroke border, when I try to make my integer number of dash patterns that make it look smooth around the circle, then I could do that for any shape, not just for circles and rectangles and polygons. So that's where this came from. And then I was like, hey, I wonder how I can do this. And I was like, oh, hey, there's a path.description property. What's that all about? And so we printed it out, and this is what spat out. So we were like, what the crap? So then we went to the Swift REPL, and we're like, hey, let's go down point by point and see what this is going on. And sure enough, what I thought were like vertical bars are actually lowercase l's. So I get something like 00M 256 0L. And what is L? I believe L is a line. However, you see L like multiple times. And I think what's happening is here, this is saying, this is moved to, maybe we move with a 256 0 line to 256 512 with a line to 0 to 512 line, and then H, I think, means close the shape. I think that's what that means. Apparently, this person on Stack Overflow also feels the same way, where they also kind of looked into this, and L is line 2, M is moved to, H is closed path, and this PDF no longer exists. So this is lost to us. Although, wait, is there like a such thing as, can we do like an internet archive? Is that possible? You don't see in the PDF spec, there's a queue operator. It's similar to or inspired by the PDF operators. We'll see. Yeah. Better option might be to enumerate its CG path using the apply with block method, which is documented. But again, I didn't see where that was documented. Like we tried to see that. What if we did this? What if we said let CG path equals my stuff dot, oh, shoot, hold on a second. I need to do a path first. I'm jumping back and forth between Xcode and the REPL. This is probably just easier to work with. Yeah. Path in rectangle is boom here. And then I can say let CG path equals path dot CG path. And then I could say let components, is that what it was? Equals CG path apply with block. Element pointer in. And if I search the documentation, you gotta be kidding me. You're not gonna help me? Oh, hold on a second. Let me get rid of this here. Then I can just say path, a description is path.description. There. I have to drop. Hey, Compile Swift, thanks for chilling with us tonight. We'll figure this out. This is fascinating. Thanks so much. Have a great Friday. Thank you for chilling with us. Okay, so apply with block. Open in developer documentation. Okay, so yeah, this doesn't give us what we need. This is not unacceptable condition. Maybe CG path element will give us a better idea what's happening. Wait, hold on a second. What is this CG PDF document? Oh boy. This is a rabbit hole, man. Later, dude. Okay, so CG path element is a data structure that provides information about a path element. So it's initialized with some type, and it's got a bunch of points. And the type is one of these guys. So again, there's a way for us to kind of like grab onto this. I know that like we can say, okay. Oh, where were we? We went back. We were in. Oh, this is game UI inspirations. I don't want you. So CG path dot components or dot what? CG path dot. Let me find all your elements. Elements? No. Path. CG path dot elements? No. I don't know what to do about CG path apply with block. Let's just try path dot element. How do I get all the different stuffs? There's an enumeration method somewhere here. I want to go back to path. CG path, that gives us the elements in the path, it says. And then you can add you can add stuff, which is great. For each. Oh, is this what I need? An element of a path. Yes. Path.element. Here we go. Getting the path elements, the case closed subpath, the case curve. And these guys are enums. So I think this path.element is like a 1-to-1 to the CG path.elements. Yeah, Animal, how's it going? 2 hours in already. Hey, wow, time flies. It's crazy. Notice the stream brought over to your YouTube channel. Yes, I'm starting to upload that stuff over there. It's just I've just forgotten to do it, you know. What I really need to do is set up like a script that automatically takes whatever's in my my video archive and just like uploads it to YouTube. But yeah, I'm starting to do that again. So actually the YouTube channel is no longer dead, you guys. Like you'll actually see new stuff in there. My VODs, which you know they delete after like 60 days. There's been some really fun interactions with you guys, and also some fun projects we've been working on that have been kind of lost forever due to Twitch getting rid of it. So I'm deciding to starting to upload those videos now, and they're like 3-4 hour long videos. They're essentially unedited VODs, is what they are. But yeah, how you doing? How you been? What's going on? What we're doing is we're deconstructing paths to essentially make better tools for our drawing library. And I've come across this very interesting path description, which is a bunch of codes that essentially it's like a string that you can generate a path from that string. So just kind of looking into this a little bit. You're busy building out your Unreal Engine 5 scene. Nice. I've seen some progress you've been making. It's been really cool to watch. Seems like you're enjoying it quite a bit. That's good. What do you think about Unreal 5 so far? It seems like it's a pretty powerful engine, huh? It's interesting how these are defined as enums. Do you see that? Case, curve to control 2. Like I didn't realize that like does that make sense? I guess it's are these associated values? Case, curve, parentheses, and then you're just labeling the different points, yeah? Isn't that what an enum basically is? Fascinating. I wonder why they did it that way. Maybe this is a way to link a string representation, almost like a JSON decoder, where you take all those elements and whoa, could we make a CG path result builder from these strings? And that's how we could support like vector files, or at least exporting them out to like a SVG format or something. Maybe. Looking to dip my toes in the programming side of it. They have enums. There you go. Everything can be an enum. Yeah, I feel like I've never seen this before, but it makes sense. Like the putting it on multiple lines is kind of throwing me off a little bit. But that's almost the same as like for example, if I were to like let's go ahead and define some enum, like my my path elements. Case quad curve. Okay. And usually like we have something that's like an integer, right? With our associated types, right? So you can have an enum and you can have it like you can initialize it with some value. But here it looks like what they've done is, and I'm just going to copy and paste this just to see what this looks like. Shut up. It's almost like basically a tuple, and that build succeeds. And so what you can do is you can just do this for all this thing, and that's what the path element is. Wow. The case closed subpath is just this. Is this like, can I get to this in code somewhere? If I go to let's go to stroke style so that we can actually open up the SwiftUI source. And now I want to go to here it is, you guys. Here it is. So frozen public enum element, and this is contained inside the struct path. Yeah, frozen. So we have an enum that's equatable. We have literally these cases where they're essentially associated values. That is so cool. That is really cool. We got move to line to quad curve to curve to closed subpath. Those are the elements that make up any path. You move somewhere, you add a line, you add a quad curve or a curve, and then you close a subpath. But wait a minute, folks. Isn't there also a path add arc? Which means, could that be the reason why when we were drawing our circle, it was showing multiple sets of those C values, which I'm guessing is a curve? This move to makes sense for M, line 2 makes sense for L, C would probably be curve, and then quad curve I haven't seen, but maybe if we did an ellipse, maybe we would see a quad curve. Yeah? And then closed subpath, this must be H, I guess. Because I think we only see it once, yeah? I think we only see H show up once. In here. Yeah, there's H all the way at the end. And then do you see it anywhere else? I only see H once. This must be the closed subpath. That's got to be it. So then by this logic, a move to would mean you got a CG point, which means you've got 2 points. Move to 226, 182. But then you've got like this other stuff. You got here, which is the origin, but it's not labeled. You've got a move to, and then you've got another 1, 2, 3, 4, 5, 6 points, 6 numbers. Then you have a curve. Oh, this is the circle. Maybe this is why. Maybe that's why. Maybe there's some sort of rotation involved. I don't know. Then you've got your C. 1, 2, and then you have an L value. 1, 2, 3, 4, 5, 6. Curve, 2 points. L, H. I know what it is. I know what it is. So you move to here, but then you have to do a curve, a line, another curve, and then a line. That must be it. It's essentially drawing the outer curve, drawing a line, drawing the inner curve, drawing a line, close subpath. Maybe. Maybe that's what it's doing. I think. But if that were the case, do you know why I think that this requires multiple curves? Because once this, like, look at the slope of the line. The slope, it starts here and like, if we're going down, it starts negative, smaller and smaller and smaller and smaller and smaller. And now like the slope is essentially 0. And then the slope changes direction. As soon as the slope changes direction, you have to create a new curve, which is why you have it like 2 new sets of curves, which is why with the circle case, it has to be drawn with 4 curves. The slope gets higher and higher in the negative direction, and then it immediately changes direction of the slope, which adds another couple of curves. So yeah, you're basically curve segments. Wow. Okay. And then again, finally here, changing it again. And boom. Hello, neighbor. Yes. Yes. Thank you. You've got a motorcycle. You're very, very cool. Very cool. Please continue to rev it. Why can't I want to be able to maximize this. Well, not in that direction. I want to give it a height. Hold on, guys. Let me mute for a second. I don't want you to have to hear this. He's gone. He's gone now. It's nice and quiet. The neighborhood can sleep once again. Very cool. Okay, I want to see a queue. I think I can get that done with an ellipse. Let's see if that's true. It reminds me of the South Park episode with the bikers. Oh man, there's a South Park situation for everything, isn't there? Oh man, that show is so brilliant. All right, let's do. Ooh, I think I think we'll find that the capsule is essentially the same thing. Should we take a look at that? Let's take a look at that. I'm just mapping this out. I know someone's already probably done it, but hey, I haven't seen a blog post on this before. Maybe my internet searching skills are terrible, but here we go. Starting out with infinity as our origin. We move to infinity. We have a line at infinity, another line at infinity, another line, and then we close. Boom. Here is an immediate move to with blah, 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 curve line, close subpath. Maybe the LH is just a line to close the subpath. Maybe it's shorthand to just go to the very first, to the origin. Maybe it knows to do that. So as it goes here, and then it, boom, this is where things change. Oh, just kidding. I forgot that this is a square frame. Hold on a second. Let's do a 512 width. All right, let's try this again. Wait, am I doing this correctly? Oh, I wasn't even affecting this. Okay, I'm doing 512. Oh. Let's try this again. So we've got same thing as before. And as soon as we hit this zero slope, we just keep on going. You see that? There's no curve to be had. It's just a bunch of lines. And as you can see here, this inner stuff starts to change. So it's almost like, yeah, what's happening here? Dang. And then as soon as we start to curve again, that's where we see another pair of C's. So here's a C, and you know, I should make this like bigger font. Let's make it bigger font. This is probably very terrible for you guys. Let's go font dot title. Let's just make it ridiculous. There we go. I should have done that from the start. There we go. Much better. Much better. Okay, so now you can see this stuff. Evaporators. Sir, my first job was programming binary load lifters. Very similar to your evaporators in most respects. Oh, snap. We got more curves, y'all. Boom. And look at this. Look at this middle stuff just like going crazy. It's like, no. What am I doing? Okay, cool. So clearly there's more than meets the eye to this situation. Because what I thought was going to happen with the capsule was that we would just see a bunch of stuff at the end continue to change, but not so. It looks like these values and these inner values have some craziness going on here. And then boom. That's where the second curve starts. Okay. Fascinating. Let's do the ellipse. I want to see some cues in there now. Show me some cues. Because if that is the case, then I feel like we're starting to get an idea of just what's in store for us here. Okay. Nah, I'm not seeing it. I have an idea. I don't know why I didn't think of this. What if we were to just generate our own custom path and kind of force this to happen? Let's force this to happen. So no longer an ellipse. We're going to be like path. Path in. Path. Move to 5. I should have done this from the very beginning. Hey, but you know, sometimes it takes a little bit to you know, just figure out what's going on. Path move to 512. Path close subpath. Yeah? Okay. Here's the simplest example we got. Nan 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 nan. Oh. What? What? Oh, this is even worse. What just happened? This is a simple path, yeah? Oh. What if I get rid of the stroke bordered modifier? What if I just say, hey, this is just me. This is my stuff. But my stuff is no longer a shape then. My stuff is actually a path. Therefore, does path.pathandRect actually work? Yes, it does. This is an extension on path, which conforms to shape. Wait a second. Is the shape protocol just regurgitating the path extension? Well, all right. So this is valid. Okay, let's see what this looks like. Are you gonna build for me? You're gonna build for me. Do it. You guys, the M comes after the move. These are the points to move to. Move to 512. This will do nothing because we're no longer tied to what the heck? Path, add line to CG point 8 24. Having to move this forward the whole time is kind of 512 move 824 line. The numbers come before the command. Okay, if that were the case, then how come why did these start with maybe even though we specify an origin as 1 to 5, maybe it's saying move to 1.5. I thought it was moving to 257.5. But what this is telling me is move to 1.5, line to 257.5, line to 257.517, line to 1.517, close shape. We did it. We did it. That's the way it goes. This is the code. You can generate Oh man, do you realize what we've done? I mean, it's always been there in the API, but dang, this is really cool. I'm very happy about this, because what this means is if I can get the path length of a line, that's easy. Yeah, you just use the hypotenuse for x and y squared, add them together, square root. There's your line. For curves, we're gonna have to do a little bit more math. Quad curves also. But what this means is that we can get, with a very high degree of accuracy, any arbitrary path shape, or any arbitrary shapes. We can get the path length of any arbitrary shape, which means we can then apply a dash pattern that will always be however many chopped up segments you want. So I no longer have to do, okay, I'm getting ahead of myself, but basically I'm no longer going to have a stroke styled circle, a stroke styled rectangle. I can just say stroke styled anything, give me your shape, and we'll cut it up into pieces for you, because we know what we're doing here now. I believe actually what we can do with this is we can access these components, because we've seen that path.element, we can using a for each, we can keep track of like the total length by just like iterating over each of the elements. And once we've iterated over each of the elements, we have our total length. And then, the user has said, hey, I want, 12 segments. And I want the dash pattern to be 50% filled, 40% unfilled, and 10% filled. You're like, that means it's going to be swapped every other one. And holy smoke, that's awesome. This is going to be, oh man. Yeah. I'm very excited about this. I know it doesn't seem like a whole lot just looking at this, but this, like being able to decode this, and I know like it's always been here, but like does anybody really like, first of all, it's clearly not well documented, or at least it's not that I could find. When you create your custom paths, maybe that's what we need to do. I'm thinking about this, yeah, it's going to have to be a deep dive lesson on this. I'm never going to be publishing these videos, all right? I'm just going to keep on adding more and more stuff to do. Okay. Let's make sure that we're doing what we need to be doing. Path.curve. Add quad curve to CG point. And we're going to go X is, what's a number we haven't used yet? 35, and Y is 42. And our control point is going to be CG point 11 and 19. $512 move, $824 line, 11, 19, 35, 42. Here we go. There's the cue. The first two numbers are the control point. The second two numbers are the 2 point. Dang, you guys. It's all coming together now. Path, add curve to. This is going to be fun. And I think this is where the 6 numbers come from with the C that we saw before with the circle. Do you guys remember that? we're totally being able to reconstruct how Swift's built-in shapes are created, which is really fun. Add curve to point. Here we're just gonna do something fun. We're gonna go 87, 88, and the control point is gonna be it's gotta be CG point. CG point 94, 95, and the other control point is going to be 100 and 101. We have our move to, we have our add line to, we have add quad curve to, we have add curve to, we have close subpath. Those are the 5 cases, yeah? I'm pretty sure that's it. So let's build that again. And bring forward. Try again. Control for a line, 11, 19, 35, 42 Q. And then now here's our C. So again, the letter comes after all the stuff that you're supposed to do, where the control points come first. Control point 1 is 94, 95. Control point 2 is 100, 101. The destination is 87, 88. And there it is. That is the recipe. Anytime you want to build a complex path, this is how you do it. Fascinating. Now, this is the path by itself. But once we start adding line widths, things get crazy, yeah? So you can see all these numbers line up. All these numbers line up. Let's just for fun, let's also add an arc. So the funny thing about this is that this is essentially a helper method that's forcing us to draw a curve that's circular. So let's do that. The center is going to be, what numbers haven't we used? Let's do everything in the 50s. We're going to go 54 to 50 to 51. The radius is going to be, let's say, 23. The start angle, okay, this is where things might get kind of crazy. We're going to go 15 degrees, and the end angle we're going to say 16 degrees. And clockwise true for whatever reason. I wonder what this is going to look like. I'm pretty sure it's going to turn this into a crazy mess. But let's see. Let's see what happens here. We're like, hey, what if I want to add an arc? Well, this is a very interesting shape. We have our 512, 824, 11, 19, 35, 42 Q. Here's our curve to 88. Okay, and then here is the next stuff. Oh, wow. Oh, wow. This stuff right here. We've got some decimal numbers. This is where things are getting crazy. So once we add arcs, now we've got... Do the numbers 50 and 51 show up here anywhere? They do not. The center, 50, 51, nowhere. Nowhere to be seen. 50 and 51 are gone. But what we are drawing... Oh, is it because the clockwise is true? I forgot. We need to flip that. Let's try this again. There, that's a lot better. Okay, so we ended at 88 curve, and then this is what we did. We did look at the resulting shape first of all. You've got you go to 512, you had a line to 824, you had a quad curve to 3542, you add a curve to 8788. Is that this? Oh, it must be because I'm going in generally an x equals y plane. So maybe what I should do is here. Let's change things up a bit here. Instead of 80, this last one was 35. Let's go back up. Let's go back up to let's say let's go to. We haven't used 25 yet. So I'm gonna do 25. Okay, I'm changing it up a little bit just so that I can see like where how this is going into play. I'm not even thinking about like the way that the display happens with like the even odd like winding rule. I don't know if like that's actually gonna be because that's what just happened. It went to 512, it went to 824, it went to 3542, but oh, it was drawing this way. Okay, so yeah, mistakes were made. But the end result is I've got a line and a curve. So the arc had as its center 5051, but that's not part of a curve. The curve is a 2 point and then the control points, but the control points come first. So even though the center is somewhere, that's not like the destination. The destination is wherever it went from 15 degrees to 16 degrees. So 16 degrees from a centered 5051 with a radius of 23 is the final point, which is why it's a decimal value. Okay. So yeah, that does make things a little different. If I were to start at 0 and go to 90, I think maybe that actually might be better for us, because then that's almost the same thing as it's essentially drawing within like a line that goes straight down. So maybe I make my center even more crazy. Maybe I make my center. Let's do something weird like 150, 150. Completely like way the heck down. And then the radius is going to be 23. Okay. I'm trying to like get it away from everything. Oh, that was terrible. That was terrible. But look at these nice whole numbers at the end. When we did it from 0 to 90 degrees, where the center was wherever it was, I guess it went here. I guess this is where it started. It went 0, and then the end angle is 90. But that doesn't look. Oh, I guess it does look like 90. Here is the center of the circle right here. It starts here. It wipes 90 degrees there. So $150 is actually showing up here. I wonder if that's a control point, isn't it? 1, 2, line. Oh, the control points start first. So this, 150, 173. Which makes sense, because if the center is in X150, and then it goes 173, 23 is the radius, then 150 plus 23 is 173, which is what we get here at our final Y point. So there it is. There it is. So an arc is made with a curve. Okay? This is essentially add curve with relative control points to make a circle, to make an arc, which is, I think, is an arc mathematically always like drawn in a circle shape? I think I'm sure. I think that's right. To make an arc, trace of circle. Okay, so this is just a helper method. It's not actually something that is this gets converted to add curve, which is cool. That's fun to know. And then close up, as always, is just H. Now I'm going to do what's called a programmer move. And we're going to go back to stroke bordered because this is going to mess things up considerably. When you do a regular path, it defaults to a stroke style with a line width of 1. But when the line width is anything different than 1, things start to get a little bit crazy. So I'm going to snapshot this. And then I'm going to do this. With a 30 line width, stroke bordered, what that means is it's inset by 15 on the X, 15 on the Y, but the actual move to, I guess, starts at the bottom. Yeah, like what we saw. So hold on to your heinies because things are about to get crazy. Okay. So you can see the path being drawn in real time. And what is happening is, it used to be, if we bring along the first image, let me go retrieve it. So things used to be nice and neat with the 512 move to, but now we don't get that anymore. We don't get a 512 move to. We get a negative 9.5 15 move to. And instead of a line to 824, we get a line to negative 6.67 27, because the stroke width, the line width of the stroke, all it's doing is it's having to like trace the inner and outer point, which means it's got to move to something else. And now it's got to do an extra line, because this first part here, whoops, this first part here, boom, this does the move to, it does the line, and then the next thing it should be doing is a Q and a C, yeah? But it doesn't do that. It does a move to, it does a line, it does another line, it does another line, and it does another line. Because it is tracing out the entire path. It's doing a move to, line, 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 line. And then as soon as things get crazy enough, once we've done the initial move to, because what this is carving out is the original move to 512. As soon as it hits that's 512, then it does this. Because once it's adding a line, wait a second. Oh, it did a move to and then add a line to 824. Once it's finished the 824, and can we see a 24 like at all? We see like a 22.4. We see it almost getting to like 24. Oh yeah, here it is, 27. Because of the width, it has to go it has to shoot past the point. And then you finally get into the second here with the quad curve. And instead of 3542, you've got this mess. And where's the Q? Do we see a Q here? We don't see a Q. We see a bunch of C's. You guys, a line width that's different than 1 means that quad curves are no longer drawn. Curves are drawn to outline the shape of the line. It has to compensate for the inner and outer part of the stroke, and that is defined as a curve rather than like a simple quad curve for the whole thing. Oh my gosh. And in fact, if we were to if we were to go as far as we could, I would venture to guess that you will never see a Q in here. It's hard to see like really anything with all of these numbers, but I just see C's and L's. I don't see a Q anywhere. And that, my friends, is how you stroke a path with a different line width. What does this mean for us when it comes to when it comes to defining the length of a path? If the length of the path can be calculated by a line width of 1, we're good. But if the line width is 30, how in the world are we going to get the path length by looking at all these path elements? Because what they're doing is they're tracing the outer stuff. Oh no. This just got a little bit harder than I thought. You know what I think? Now I recall like an old Stack Overflow answer somewhere where they had to do basically like a piecewise integration of an arbitrary path. Maybe it's because of stuff like this. If you can't, you got to deal with the line width. I mean, you could. If you're trying to recreate a path with a description like this, how are you going to pull out the simple quad stuff? The simple quad stuff. How are you going to do that? You can't. Holy moly. Things just got crazier. Okay. Okay. Like much easier to get a length with this from 512 to 824. That's 3 squared plus 12 squared square root. 9 plus 144 whatever. Square root. How am I going to do that with this? Oh no. All right. All right. I wonder if there's some sort of like maybe rounding that we could do. If we were to calculate the stroke style of the line width 1 that's drawing this path, we could go one way, but coming back from the other way to like do the calculation is going to be harder, of course. But if we're given a shape and the user says, hey, I want to draw this with a line width of whatever. And we can be like, okay, I've already got the path. Now what we can do is we can generate a different path that's assuming a line width of 1. Get the approximate length of that, or get, whatever that path length is. And then we're like, okay, if we were to make this whatever line width it is, I guess depending on the line cap and the line join, remember it'll stroke something out. And we haven't even looked at this. We haven't even looked at like different line joins and line caps, which tell you in the documentation that it'll actually draw a little bit extra. Okay. But at least what I gather from this information is that we can store paths as strings and generate paths from those strings with that initializer. And that's one cool thing that we can do. The generating the path length is going to be a harder problem. But wow, fascinating. Okay, you guys, I said I would move on from this. I think I'm finally going to move on to the next thing. We got like an hour left. What I wanted to focus on next is how to create an animated clip shape. So we've got views that can have clip shapes in them, yeah? You may recall on a previous stream that we did something like this with an animated stroke style. And the idea would be similar, but I haven't been able to do that with a clip shape yet. So let me show you what I mean. So we had, I don't think it was in this project. I think it was it in this one? The shapes tutorial? There's a lot of commented code there. This is it. Check out this beauty. Eventually. Oh, for Pete's sake. While we're waiting for that. We have our defined shape. We have it inset by some amount. Then we use this animated border. Yeah. I've got a stroke style that, depending on whether or not it's animating, is a certain line width, and the dash phase is also changing. Then I say stroke style. What I've got here is a Z stack with 3 of these guys with different insets. So this animated border inset 5, animated border inset 25, animated border 50. Yeah. So this function animated border basically calls a circle. It insets by an amount. It then strokes by a style that is animated, and that's why you get to see this really cool stuff. There's a second pass of the stroke to just get some interesting interactions. And then the final stroke modifier is what causes this stencil effect. This has an animation that's a linear duration of 5. It repeats forever. It auto reverses. value animating. This is your standard way of animating a view. And what happens with this is, because the animation is called on this, it's got in the Z stack, and everything inside the Z stack has a foreground style, which is a linear gradient between red and purple from the top leading to the bottom trailing. Now, what I wanted to look into is, can I use this stroke style on a shape as a clip shape of something else? So your standard clip shape, or clipped by, is like a static shape, yeah? So let's look at this, and let's take a look at maybe we can have something in the center. So that'd be kind of fun. So what I'm going to do now is I'm going to take a let's go with a rectangle, just any shape, and I want to have it clip a clip shape of, well, let's do a circle just to see what we got. Okay. Now this is taking up a lot of space. So what I need to do is I need to do a frame of let's do a width of 100 and height of 100. So that's a rectangle. It's clip shaped circle. I'm gonna highlight in yellow the border of the actual shape. So maybe I do a 200 by a 100. There's my rectangle. It's clipped by a circle. Okay, that's cool. I would like to clip this with something that's animating. Can I do that? That is the question. Well, we know that, like, if we do dot stroke style, this is defined stroke style as, if it's animating, a line width of 10 and a dash phase of 105, which seems to track. Our dash is 2010.5. That doesn't change. But the dash phase is 105 because as soon as the view appears, animating is true. And as you can see, it doesn't move because there's no animation modifier to it. Now, what I want to know is, can this be applied to this? Okay, it's still static. What if I do it here? Okay. Would you look at that? Very interesting. What does this mean for us? It means that we can have a clip shape that has animatable properties. Can we do it twice? We can. Again, this is a clip shape. So this could be a clip shape on... What if I did this on something else? What if I did this on a capsule? It probably, you know what we probably need to do is put this on. I need a clipping shape that is outside of the original shape. Let's try that. Let's try a circle, and the clip shape is a capsule with that same stroke style. Okay. Now that is interesting. Let's just do a single path. Looking good. Thank you, Ploppy. Zoom on in here. So this clip shape is fine. What if I do... The clip shape is a capsule. What if I'm a rectangle with a capsule? Oh, look at that. What did we just see here? So our clip shape, when it's a capsule, and capsules are affected by the frame, right? Like when we had our original shape, a circle, circles only get drawn as circles, even when you have a frame modifier that has different widths and heights. So when you have a frame modifier different widths and heights on a circle, your clip shape, even if it's a capsule, is not going to appear as a capsule. But if your shape is a rectangle taking up the entire width and height, now the capsule can do its job. Which... Now let's do 2. Okay. Oh, and then I think what we were doing all the way here was line with the 2 out the end, right? So let's do that as well. Let's make it look like the outer rings. Okay. So I can what about this? Oh, okay. Okay, look at this. Now this is something. This is interesting. This is so this is an ellipse. The clip shape is a capsule, and the capsule is... You see that there's some missing information here, right? If I were to do just an ellipse, that's what the ellipse looks like. So you can kind of see where it is, but the clip shape is actually the clip shape is larger than the original shape, and so like you're gonna get this clipping effect. So like there's nothing in here. If we did a clip without the strokes, you just have a clip shape of a capsule and everything is filled. It's only when you do a stroke that you get that interesting pattern. And yeah, that border color yellow, I'm going to give it an opacity of so that it's not so prominent. Let's go 0.2. Yeah, yeah. Just enough to see like where our frame is. So this is quite interesting because your clip shape is a stroked shape. And because it's outside the lines of the frame, you get this like, it's almost like you feel like something's not all there. Let's take away the border. Is animatable. You're performing an animation pass on a shape with a clip shape that has animatable properties. This ellipse doesn't have animatable properties. I mean, we could do the very same thing. We could do this. We could say, hey, give the ellipse a stroke style stroke clipped with a capsule. So now you've got like this very weird, it's got like differing like line widths. I mean, it already does, but like it's got this very strange effect going on. Okay. And then back to, let's see, was it the line width 2? I think that's where things got all. Okay. So an animation view modifier can be applied to any shape or any view, and the clip shape can have animatable properties in it, and it'll respond positively to that. What happens if I decide to rotate my shape while keeping the clip shape the same? Rotation. Animating. Dot degrees 90. Otherwise 0. It's almost imperceptible, like what the end result is. Let me take out these modifiers and let's see what this looks like. So the rounded rectangle itself has an animating stroke style, and then is being clipped by a normal shape. But if we also apply that stroke to the clipping shape, then it almost seems like it's too vague to be really anything. So maybe I don't do a stroke on the rectangle. Ooh. Now that is interesting. That is a cool effect. It's almost like, what is even happening here? The rectangle is going 90 degrees. Can I do, let's bring the border back. The border's going to stay constant. But you can see that it's essentially shifting 90 degrees. Is there a way to trace? Is there a way to trace that? So I can see, I guess I could just do this. Just so we could see it on top of each other. Oh, whoops. Sorry. Sorry. What's the best way to do this? I guess I could make it a Z stack. Because what this has the effect of doing is it's almost like you're taking like the original shape, a capsule, and you're overlaying, you're basically giving it two trimmed paths. But it's just a rectangle being clipped by a capsule and the rectangle happens to be rotating. And so you get this optical illusion of the capsule changing its from and to trim in two different places, which is kind of fun. So like if I were to go to like 180 degrees, what if auto reverses is false, which means we're going to constantly. Now that looks like a pretty cool loading animation. Let's go all the way to 360. So it's going to go all the way around. It's going to go fast now. And what we're going to do is we're going to get rid of the border again, and just see if we can create something fun. Look at this. That's there's a little bit of a weird jump. I think if we did an ease in out, then that might be better. Oh, it's still kind of skipping a bit, isn't it? Let's try building again and seeing if it just wasn't getting confused. What is happening there? The capsule's not like, let's give it a fatty thickness. Let's go 10 on the stroke. Okay. Now I can see what's happening. You guys can see easier. You can your eyes are probably telling you where the rectangle's going. And here's the rub. As you get bigger in stroke, your the rounded rectangle, I guess it doesn't even matter what the roundedness is. Let's go 50. You can see like as the capsule increases in line width, you start to see the original shape. And then it has a completely different effect. Which is still kind of cool. But what if we went stroke bordered? Oh, this doesn't. Dang it! I gotta create this again. Hold on a second. I gotta copy and paste this. Let's copy and paste this. There we go. There we don't go. Hold on a second. What don't you like? Oh, extraneous argument label. There we go. Okay. There we go. Okay, so yeah, I mean now you can tell. That's an interesting effect. But you can clearly see. Yeah, even with like a line width of 1, you're gonna see some tearing, as the shape's boundaries. What if I do just a rectangle, no corner radius, and then what if I do Hey, have a good time at the gym, Ploppy. Thanks for chilling with us. Thank you, thank you. There you go, bigger stroke border. Yeah, you can see how like the rectangle, because it shares the same frame as the capsule. If I were to do something like add padding, would that even work? Oh, am I getting a failure to build? It cannot infer a contextual basis. Well, you can't do padding apparently on this. Can I do padding here with a clip shape? Yes. What the heck? Ooh, that's interesting. Okay, there's the stroke bordered. Okay, cool, cool. It's almost like a reverse mask effect. Like the actual clipping shape is the blue. Like the original shape is the one that's rotating, but the clip shape is like doing this like almost like a reverse reverse mask. Guys, I think I just broke it with the stroke bordered. Look how it's static now. It no longer animates. If I take out the stroke bordered, now I see animation going on in the well, that is cool. I see animation going on, and wait a second though. If it's stroke bordered, can I do the stroke animation like first? So that's static. Can I put it up here? Oh, what? What is this? Hey, let's not rotate you. Let me just see what this looks like by itself. Take out the padding. They're going in reverse directions when you stroke border it. Why? Why is that happening? Okay. Capsule with a stroke, with a single stroke style. Yeah. The stroke style is 10 of a line width if it's animating, 2 if it's not. So you can see it's getting bigger and smaller as it goes back and forth. The dash phase is what causes it to rotate or to move. That's the secret. It's moving because of the dash phase. If I do 2 stroke styles, do the stroke style on top of each other, they're kind of like they're fighting with one another. They're kind of overlaid and doing this like canceling out pattern. But if I instead make it a stroke bordered, now it's performing a stroke on both the inner and outer portions of the already stroked shape. You could probably even have this effect if you did not just stroke border, but just stroke like, with a line width of 20, right? It probably would do the same thing. Yeah, it does the same thing. And what does that mean? Does that mean that the underlying line width traces the inner path in a reverse direction? Because otherwise, like, how would we not know? How would we know that unless we were animating the dash phase? So, is this the odd even rule at work? Is that what's happening here? Oh my gosh. Is there an incentive to go one over the other? I don't know if I see a difference between stroke bordered and stroke. Maybe I do. Holy crap, that is cool. That's like a weird border pixelation effect. Holy smoke. Well, now I'm sleepy. I feel like I'm getting hypnotized right now. Yeah, even without our stroke bordered addition to the shape type, we can still get some very interesting effects with using a clip shape, using an animated clip shape. Yes, that's dang. How fun is this? This is really cool. What applications do we have other than looking at spinning shapes? One of the reasons why I looked into like an animating stroke style was because of, for a user interface where you're where the user is being directed to a specific UI element. Like a highlighted button, let's say, or maybe it's an edit tool. Maybe you've done a lasso around some space that you want to move or cut or something, and to have that border that's animating. That's kind of what I was going for, but like this is kind of like a bonus side effect of drawing things with several passes at these stroke styles, which is really fun. Guys, we need our pal Rulo in here. We need our Rulo triangle, and this is, I don't know if he's even in this. Oh yeah, he is. There we go. Oh, the shapes library is totally here, dude. Mr. Rulo with a clip shape. What does that even look like? Oh, you can't even tell. You can't even tell where he is. That is funny. You can't even tell him where he is. What if I did this? No, Mr. Rulo is not a shape. He's a view. What if I did a rotation? What? Oh, I think it has to be a rotation effect. Yeah. You can't even tell. Okay, so instead of that, what if we make it Rulo? Oh, I need to import shapes. All right, here we go. Rulo triangle. I think this will work, yeah? Yeah, baby. Look at that perfect shape. Oh, that's so freaking cool. this background music is almost the perfect combo to like lull me to sleep here. I go stroke bordered. Like give me more of a. Oh, that's weird. Holy smoke, what is that? What's going on here? Oh, see that final looking dang, this is some abstract psychedelic stuff, man. Okay. This is, just chilling. Just chilling like a villain. But then boom, we bring the stroke style. This is where things get cray. Maybe you don't even need a stroke bordered. So cool. Seems like the shapes to be clipped, if they've got like a more complex geometry, it's probably not as interesting. What if we did a completely different approach? I mean, it's got a little bit of a pixelation effect with that one. I kind of want to do like a repeating pattern though. I want to see let's see. What would be a way to do that? I know there's a way to do it with what is it called? What's the image paint initializer look like? Image paint, image system name, Swift. Value of type image paint. Oh. No? Value of type image paint has no member clip shape. Oh, it doesn't? How do I utilize this? Oh, it's a shape style. A shape style that fills a shape by repeating a region of an image. Okay, so what if I do this? So what if instead of my foreground style being color.blue, it was just going to be a rectangle with a foreground style of, you guessed it, image paint. Uh-oh. That did not work. That did not work. Wait, can't I? If I do a foreground style first, what if I fill with the fill style? Ah, there we go. This is what I needed. Okay, so I needed to do a fill with the image paint beforehand, and then I can use my clip shape that's animated. And now I get an interesting clip version of these Swift. Okay, so this is whoops. So there's a pattern image. Cool. Does scaled to fit not work for image? Does that? Yeah, it turns it into a view. So I have to keep it as just image resizable. What if I start rotating you, man? All right. Folks, it's about that time. Hey, this was a fun exploration. What did we do today? Well, we created a fun extension to Shape, which allows us to draw within the lines as a stroke border modifier. Taking in a trim value, we can actually trim a stroke bordered shape and keep it as a shape, which is huge. Can help us make some really cool choices in the way that we utilize clipping shape. And we've seen that itself can animate as a clipping shape. So fun stuff. We also explored generating paths through numbers, through we saw was a description, which is it's got a bunch of encoded commands to move, add lines, curves, and quad curves. And we've also seen that if you supply it with a line with anything that's greater than 1, or probably even less than 1, we didn't even try the less than 1 case, did we? Well, anyway, if it's larger than 1, it no longer gives us a simple formula for creating the path. It also has to take into account drawing the outer and inner lines of that line width, which makes for a crazy interpretation of the results. I'd like to pursue this particular thing further because I want to see if I can estimate a path length so that we can create a generic stroke styled shape that can give us dash patterns that for continuity, so that it doesn't break at like 0 and 360 degrees, for example. So I think I'm going to pursue that a little bit more. I don't know when, but yeah, it's going to be in our bag of things to try. We're going to end tonight. Saturday is going to be, hopefully, our stream that is going to be redrawing some UI from the classic N64 game GoldenEye. So please stay tuned for that. And hey guys, it's time to go. Thanks for the chats tonight. Thanks for all of the support. I will see you in a couple days. Bye-bye.